Assalamualaikum, my name is Alisa Fatin Binti Ramli, and now I will be presenting my research on physicochemical properties of palm milk as a plant-based cheese. The global cheese market is growing rapidly, and in Malaysia alone, the industry was valued at 19.5 million in 2018. At the same time, the demand for plant-based cheese is increasing, driven by health concerns, the rise of vegan lifestyle, and also lactose intolerance. Palm milk, a plant-based alternative rich in vitamins, cholesterol-free, and with a comparable fat profile to dairy milk, has a great potential in cheese production. However, studies on its application in cheese making are still limited. Therefore, this study explored the feasibility of using palm milk as a raw ingredient for plant-based cheese production. Currently, a plant-based cheese alternative are gaining popularity, especially among the consumers with dietary restrictions, such as those with lactose intolerance or milk allergies. However, many existing plant-based cheese use soy, almond, or coconut milk, while palm milk remains unexplored despite its nutritional benefits. Malaysia is the world's second largest producer of palm oil, making palm milk a readily available and sustainable raw material. There is a need to investigate its characteristics compared to conventional dairy cheese. This research is highly relevant to Sustainable Development Goal SDG 12, which is responsible consumption and production, which focus on minimizing waste, improving resource efficiency, and promoting sustainable food system. This study maximized the utilization of palm-based products and reduced reliance on traditional dairy sources. Additionally, palm milk serves various applications beyond cooking, including as a dairy alternative, thus incorporating it into cheese production diversity. Its usage and minimize waste by ensuring that palm oil byproducts are fully utilized. Ultimately, the development of palm milk-based cheese contributes to a more sustainable, waste-reducing, and also health-conscious food industry. The first objective is to produce plant-based cheese using palm milk as a raw material. Second, to determine the ideal processing condition of the produced cream cheese. And lastly, to determine the physicochemical characteristic of the plant-based cheese. For literature review. First, palm milk as a potential raw material for cheese. Malaysia has a huge area committed to oil palm farming, about 5.67 million hectares, which is almost 70% of Malaysia's total land area. This indicates that palm milk has the potential as a raw material for producing plant-based cheese, ensuring consistent and considerable accessibility to palm oil, ensuring it is a reliable supply of palm milk. Not many people know that palm milk has a good nutritional content and functional properties. Palm milk contains naturally occurring vitamin E, which help product stability. These antioxidants also help maintain the cheese texture and consistency. Second, the quality of cheese. By comparing these qualities between plant-based and commercial cheese, we can identify areas where plant-based options need improvement for enhancing the overall quality of plant-based cheese made from palm milk. And third, process of cheese. By examining the different process, we can identify how plant-based cheese production can be optimized to better mimic traditional cheese. This is the methodology for processing palm milk cheese. The amount of Lactococcus lactis used follows the instruction provided by the supplier. The pictures display the result of the processing for both palm milk and the control sample. The control sample is made using the fresh milk. The findings indicate that on day 1, the pH of PMC started at 6.31 and 6.20. By day 2, it drops to 5.66 and 4.83, marking the onset of lactic acid production. On day 3, the pH further declined, and in contrast, the CC experienced a more rapid acidification, with its pH reaching 4.35 by day 1 at 30 degrees Celsius, where PMC took longer to reach a similar range. This lower acidification in PMC could be attributed to difference in sugar composition, as cow milk contains lactose, which is readily fermented by Lactococcus lactis, while palm milk lacks lactose, potentially slowing the acid production. Additionally, variation in protein content, particularly the absence of casein in PMC, may reduce its buffering capacity, further delaying the pH reduction. The result of this study shows that the PMC had significantly higher firmness compared to the control cheese. Duncan tests confirmed a statistically significant difference, placing them in separate groups. This indicates that PMC has a texture closer to semi-soft cheese. When compared to previous studies, conventional cream cheese is reported to have a much softer texture. A study published in the Korean Journal for Food Science of Animal Resource found that cream cheese made from whole milk powder had a lower hardness value, meaning it remains soft and spreadable. Additionally, the firmness of PMC on day 2 was recorded at 165.19 gram, which aligned closely with the findings of previous research. The color difference between PMC and CC was assessed through visual analysis and instrumental color measurements, with PMC exhibiting a slightly more yellowish hue compared to CC. PMC exhibited a slight yellowish hue due to the natural pigments in palm milk, primarily carotenoids. Duncan's test confirmed a significant color difference which can influence consumer perceptions. Carotenoids, especially beta-carotene found in palm oil, are responsible for the yellow to reddish tints in foods. As palm milk contains this pigment, its cheese naturally develops a yellowish tone. In contrast, commercial cream cheese are typically characterized by uniform white to light cream color. Degrees Briggs measure the total soluble solids, primarily sugars, in the samples. According to a study, the Briggs values of cheese analog that made from sweet corn extract contain 19 degrees Briggs. The initial Briggs value for palm milk was 25.67, which is significantly higher than the control milk at 14. This indicates that palm milk contains more natural sugar. After fermentation, the Briggs level in palm milk cheese decreased to 8, which showing the significant sugar consumption by Lactococcus lactis, which convert the sugar into the lactic acid. This is an expected result as fermentation reduces sugar content in cheese production. Duncan tests confirmed significant difference between all samples, with PM forming a separate group from the others indicate significant difference in sugar reduction across the samples. The initial pH of palm milk was 6.20, similar to control milk at 6.22. After fermentation, PMC had a final pH of 4.76, indicating successful acid production by Lactococcus lactis. The control cheese had a lower pH, meaning it acidified faster. The slower acidification of PMC may be due to the difference in sugar content and protein composition between palm milk and cow's milk. However, PMC final pH falls within the normal range for soft cheese, making it suitable plant-based alternative. There is a significant difference among the means of the samples except between palm milk and control, which are in the same group. Moisture content plays a key role in the cheese texture. PMC had a significantly lower moisture content compared to CC. The lack of casein in palm meat contributes to a lower moisture retention as casein micelles in dairy cheese help trap the water. Duncan's test confirmed significant difference within PMC, forming a distinct group due to its drier consistency. Comparatively, dairy cream cheese contains 70% moisture, where soy-based cheese range from 35 until 50%, indicating the PMC align with common plant-based cheese trends. In this study, palm milk had a higher fat content compared to control milk, which is expected as palm milk is derived from oil palm, naturally containing more fat. During the cheese making process, the fat content increased due to the concentration effect as moisture retention during curd formation lead to a higher fat concentration. As a result, palm milk cheese recorded a fat content 3.65, while control cheese had 0.44%. Duncan test confirmed a significant difference between PMC and CC, placing them in separate groups. Compared to commercial cream cheese, which contains 30 until 40% fat, PMC remains a low-fat alternative, offering a healthier choice for consumers seeking to reduce their fat intake. The result shows that PMC had a significantly higher protein content than CC, making PMC a nutritional superior alternative. The higher protein content in PMC can be attributed to palm milk's naturally high protein composition and the effect of microbial fermentation with Lactococcus lactis, which enhance protein availability by breaking down larger proteins into smaller peptides and amino acids. Unlike conventional cheese, which relies on casein for structure, plant-based cheese like PMC lack caseins, making them structurally different. However, its higher protein content suggests that PMC could be used for firmer cheese variety. In conclusion, this study successfully demonstrates that palm milk can be used to produce plant-based cheese with unique physicochemical properties. PMC exhibited lower fat and higher protein content compared to commercial dairy cheese while maintaining proper pH and degree Brix value, indicating adequate fermentation. The ideal processing temperature for PMC was 37 degrees Celsius as it resulted in a texture, color, and acidity level comparable to the commercial cheese. These findings suggest that palm milk cheese could serve a promising alternative for consumers seeking a dairy-free, lower-fat cheese option. There is several key challenges in making plant-based cheese, including a lack of flavor and a distinct odor. To improve this aspect, I recommend incorporating enzymes into the process. Additionally, further exploration of the curdling effect is needed to better replicate the texture and functionality of the commercial cheese. Identifying the most suitable temperature and processing condition is also crucial, as these factors significantly influence the final texture, acidity, and overall quality of the cheese. That's all from me. Thank you.